Welcome to the first section of Dermatology in General Practice, Skin Structure Overview. In the next 15 minutes, you'll review the main layers and functions of the skin and what allows the skin to be a protective barrier. We'll talk about how skin helps with temperature regulation and what the purpose of sebaceous glands are. We'll talk about whether or not dogs and cats sweat and whether a gorgeous hair coat has a role beyond looking great. Do you know what the largest organ is for a dog or cat? It's the skin. You might be surprised to learn that skin accounts for up to 25% of a dog or cat's weight. Skin is essential to life. The skin provides a protective barrier against the environment, helps regulate temperature, and provides a sense of touch. The skin has three main layers: the epidermis, or outer layer, the dermis, or middle layer, and the subcutis, or the innermost layer. There are other important parts of the skin, including skin appendages, such as glands, hair follicles, paw pads, and nails and claws. Let's review the composition of the epidermis. The epidermis itself has several layers, and the thickness varies with location. It provides protection from foreign substances, injury, and UV light damage. The epidermis is constantly regenerating. The epidermis is very biologically active. New skin cells are created near the base and migrate upwards, meanwhile producing keratin protein bundles within the cells. This produces a compact surface layer of keratinized cells. This layer of cells keeps in fluids, salts, nutrients, and water while keeping out infectious or noxious agents. The top layer of cells are continuously shed and replaced. The rate of cell replacement is affected by nutrition, hormones, tissue factors, immune cells in the skin, and genetics. Disease, some drugs, and inflammation also alter normal cell growth and keratinization. If the epidermis is a layer of dead cells, why does our skin not look like this? The in-between bits are as important as the keratinization. Think about bricks and mortar. The mortar is essential. In the skin, the mortar is an important layer of long-chain fatty acids, ceramides, special lipid molecules, and cholesterol. The skin barrier protects against mechanical damage, noxious substances, pathogens, and water loss. In the final phase with their resistant cell exteriors and internal keratin bundles, they are the bricks. Bricks are the physical barrier. In their formation, they also release antimicrobial products called defensins. The secreted lipids form the mortar. They keep in water provided by the deeper layers, contribute to elasticity, and maintain an acid pH. The skin barrier includes the resident bacteria. Cutaneous microbiota diversity correlates with skin barrier function and clinical signs in atopic dermatitis. Beyond the 85 to 90% of keratinocytes and lipids, what other cells are present? There are other specialized cells, including melanocytes, the Langerhans cells, and Merkel cells. Each of these cells has special functions. Melanocytes produce pigment, the melanin. Langerhans are involved in immune function. Merkel cells are involved with neurosensory function or touch. Let's look at the epidermis under the microscope. The melanocytes, where the arrows are pointing, are located at the base of the epidermis, the outer root sheath of hairs, and the ducts of the oil and sweat glands. Melanocytes produce the skin and hair pigment called melanin. They themselves are clear. The pigment gets transferred to the keratinocytes of the skin and the hair shaft. Production of melanin is controlled by both hormones and genetics. Can you see the brown melanin pigment? Do you know if it has a function beyond color? Cells in the epidermis can be damaged by excessive ultraviolet light exposure. The presence of melanin helps protect the cells from the damaging rays of the sun. Can you find the epidermal Langerhans cells? They are the immune system stars. Why are the Langerhans cells important? Within the epidermis, they serve as part of the immune function network. They act as sentinels and can alert the rest of the immune system to danger in the environment. They also play an important role in the skin's response to foreign substances and contribute to such things as the development of rashes when an animal is exposed to irritating materials. Cats have specialized sensory cells associated with the whiskers and certain hair follicles that provide an improved sense of touch. Where does that whisker superpower and touch sensation come from? The Merkel cells. Those are the cells specialized to respond to light touch on the skin. They're also associated with the sensory organs in whiskers and other tactile hairs. Free nerve endings in the epidermis respond to painful stimuli, temperature, movement, and itch. Let's trek on down to the next and the largest layer, the dermis. To do that, one must traverse the basement membrane. The basement membrane anchors the base of the epidermis to the dermis layer below. It maintains tissue architecture and participates in wound healing. It serves as a protective physical barrier between the epidermis and the dermis. Several skin diseases, including a number of autoimmune conditions, can damage the basement membrane zone. Can you explain why a scratch doesn't always bleed? How does the epidermis receive nutrients? The dermis is rich in blood supply. The dermis supports and nourishes the epidermis and skin appendages. A network of blood vessels supplies the epidermis with nutrients. Blood vessels are also responsible for regulating skin and body temperature. Remember when we talked about superficial touch and whisker power? What about other types of touch? The sensory motor headquarters. Sensory and motor nerves are located in the dermis and hair follicles. Many other sensations are related to specialized nerve bodies within the dermis. These respond to a variety of sensations. Fine discriminative touch to continuous pressure, deep pressure, and vibration. Overall, the skin responds to the various sensations of touch, pain, itch, heat, and cold. The dermis is rich in connective tissue, which produces collagen proteins that support the skin and provide strength. There are also immune cells in the dermis that defend against infectious agents that pass through the epidermis. The subcutis, not subpar at all. The subcutis layer contains subcutaneous fat for insulation, padding, and energy reserves. It allows the skin to move freely. The twitch muscles are also in this layer. Look at that skin twitch. What comes to mind when you hear the term appendages? Hair follicles, oil and sweat glands, nails, and claws are all skin appendages. Skin appendages are named as such because they grow out of the epidermis and the dermis. Hair follicles, found in the dermis. Hair follicles change with age. The hair follicles of dogs and cats are compound. They have a central hair surrounded by 3 to 15 smaller hairs, all exiting from a common pore. Puppies and kittens are born with simple hair follicles that develop into compound hair follicles. What part of hair physiology can drive owners crazy? It's the shedding, of course. Let's look at control of hair growth and shedding. The growth of hair is affected by nutrition, hormones, and a change of seasons. Dogs and cats normally shed hair in the early spring and early fall. They may also shed in response to changes in temperature or the amount of sunlight. The size, shape, and length of hair are all controlled by genetics. Hormones have a significant effect on the growth of hair. Disease, drugs, nutrition, and environment also affect the health of hair. Did you know that hair color is temperature dependent in certain feline breeds? The hair coat also provides the skin with protection from physical and ultraviolet light damage and helps regulate body temperature. Trapping air between secondary hairs conserves heat. This requires that the hairs be dry and waterproof. The cold weather coat of many animals is often longer and finer to facilitate this heat conservation. The hair coat can also help cool the skin. The warm weather coat has shorter, thicker hairs and fewer secondary hairs. This anatomic change allows air to move easily through the coat, which facilitates cooling. And a built-in camouflage. Can you think of a wild animal whose hair coat provides camouflage mastery? The Arctic hare has amazing hair. Sebaceous glands. Oil glands, also called sebaceous glands, secrete an oily substance called sebum into the hair follicles and onto the skin. They are present in large numbers on the face, paws, back of the neck, rump, chin, and tail area. Sebaceous glands are also part of the scent marking system. Cats mark territories by rubbing their face on objects and depositing a layer of sebum laced with feline facial pheromones. Dogs mark their territory by digging or kicking their paws into the ground, depositing their sebum. Scent and sheen. Sebum is form and function. Sebum is a mixture of fatty acids. It is important for keeping the skin soft and pliable and for maintaining proper hydration. Sebum gives the hair coat sheen and has antimicrobial properties. Let's talk about sweating. Cats and dogs have sweat glands on their feet that may have a minor role in cooling the body. They will also sweat through their paws when they're excited or nervous. For temperature regulation, cats primarily regulate their temperature by grooming. They spread their saliva on their skin and sometimes by panting or drooling. Dogs primarily release excess body heat by panting and drooling. Skin and coat are vital to a dog and cat's health. They are a key component of the immune system. They provide protection from external threats, both physical and infectious. They have nerve endings that sense heat, cold, pressure, and pain to signal to the pet to protect themselves. Very critical for thermoregulation and hydration. Also for nutrient storage and shock absorption. Is it fair to judge a patient's overall health by the health of their skin and coat? The short answer is yes. A healthy skin and coat can be a key indicator of the overall health in a dog or cat. A dry, flaky coat or other skin changes could be a sign of underlying disease, be it nutritional, hormonal, as well as other organ dysfunctions like liver, kidney, or gastrointestinal. We have more 15-minute takeaways coming up next, so grab your next coffee break for part 2, something that comes in your door every single week, allergic skin disease. Thanks for joining us for part 1.